Now, having understood the initial basic concepts of circular motion, the related terms, we can easily go ahead for its special case discussion of conical pendulum. This. The conical pendulum is rather a motion of a simple pendulum to form an imaginary cone shape. Like, suppose if we have a pendulum of, let us say, length L. Deliberately, I'm showing it like this. This is actually the length of pendulum, where this bob is connected at its one of the end. And then if this bob and the pendulum actually is taking a turn in a horizontal plane like this, we can imagine that they are actually enclosing a cone-like structure, and hence the name conical pendulum. Now, if we just really apply the common sense side, we can simply say that this distance represents the height of the cone. This represents the height of the cone. So if this is the length of pendulum and if it is taking a conical shape, this becomes the height of pendulum. Listen here now. Once the bob is here, we know that its weight, I'll use some other ink point, its weight mg will be always acting downward. This mg is balanced by one force which is exactly in opposite direction, and that force is actually T cos theta. Now what is T cos theta? Is basically when we have a pendulum, there is always a tension in the string. This is the tension. Now this tension is resolved into two components. This component T cos theta and this side component. And this side component is T sin theta. So we have resolved tension into two components, T cos theta and T sin theta. So T cos theta is balancing mg, whereas T sin theta is balancing for that centripetal force. So we can write down these simple two equations for this conical pendulum like T cos theta is balancing weight and T sin theta is balancing centripetal force, which is mv square by r. Now what's m? Mass of that pendulum. V, velocity with which it is moving, and r is nothing but radius of this imaginary circle. The bottom of the cone, that is basically this radius r. So what happens if we actually try to calculate something from these two equations like T sin theta divided by T cos theta? We know T and T will get cancelled, and somewhere we are left out with the term tan theta on our left hand side. See the right hand side. It will be as if I can simply say that this will be mv square by r divided by mg. So I can easily cancel m and m, leaving behind it's a v square divided by rg. Now what we get from this part is v square is equal to rg. into tan theta, and that's nothing but V is equal to root of Rg tan theta. Now, in this equation, if we just look out where theta is, so we are actually talking about this angle as theta. That's the angle theta. And now, then it starts a very simple concept, like we know the equation as time is equal to distance covered divided by speed or velocity, isn't it? So we can simply say that using this part, we can simply say that time period t is equal to distance. How much is the distance covered? So it's like one complete circumference of this circle, which is, we can simply say that it's a 2 pi r. That's the distance covered divided by v. But we know what's the value of v? Rg tan theta. So I can simply say that this will be like 2 pi r. It's like 2 pi r divided by root of Rg tan theta. 2 pi r into this value, that Rg tan theta. We just adjust the terms and we can simply say that it can be written as 2 pi taken common under root of, I can simply say that this is r square because I'm taking this r inside the root, divided by Rg tan theta, which I can cancel 1r with r, giving me that equation like it's a 2 pi root of r divided by g into tan theta. This is one formula that we can easily use. But if we just look into this r, if we just look into this r, I can simply say that this can also be written as root of L into sine theta, root of L into sine theta divided by G into tan theta. We can easily write down tan theta as sine theta divided by cos theta. This is just manipulation part. What formula we have used here? So we can simply say that onto this part, I can say that sine theta is equal to r divided by L, that is r equals to L into sine theta. This is what is from the diagram which we have used here. Now I can cancel out sine theta with sine theta, giving me the equation, the final equation, like t is equal to 2 pi under root of L into cos theta, L into cos theta divided by G. This is the final equation which gives us the equation for the time period of the conical pendulum. If we extend it to the next part, we can simply say that we get the equation t equals to 2 pi root L into cos theta. I'm so sorry, just 1 minute. Yeah. L into cos theta divided by G. And here comes the next discussion, like when theta is very small, when theta is very small, we can apply the condition, cos theta nearly equal to 1. How? Again trigonometry. Cos of 0 is equal to 1. Cos of 0 degree is equal to 1. So if the angle is too small, if the angle is approaching towards 0, what has happened? We can simply say that theta becomes 0. As theta becomes 0, cos theta becomes 1. And we get the final equation T is equal to 2 pi under root L divided by G, which is the very familiar equation that we have used for the simple pendulum. This is the equation which we have used for simple pendulum. Most of the problems, they are based on this simple understanding, where we just have to apply our basic knowledge and find out the needed ask parameter. Hope this is clear to all.